has been invited as a resource person for numerous FDPs and academic programs. His career includes leadership roles in Fixed Dynamics, Gadgian, and Mercedes-Benz R&D India, along with strong academic credentials, including GATE and UGC NET qualifications. Today, he is taking a session on a peek into LLMs. We warmly welcome you, sir, to handle today's session. Thank you for accepting our invitation, sir.
Okay, can we start?
Yes.
Yes, sir.
Evening all. So today we are focusing on practical implementation of large language model. Okay, so uh, we may heard about large language models in every day in our life, right? It is not just a research or hype now because lot of practical applications are coming, and it is already implemented across different industries now. So over the next 1 hour, I'm going to talk about the real use cases in five major areas or five major industries like BFSI, that means banking and finance sector. Then we have the uh, automotive sector, legal sector, then education. So we will talk some real use cases that has been already implemented, or that is going to be the next level products in those industries. Okay, so before going to the details of those use cases, I'm starting with the LLM revolution. So how the LLM revolution is transforming the business? Okay, because uh, when we have a new technology with us, basically it has to be implemented in different industries. So when we are implementing these in different industries, they should have there should be they should have an impact that technology on their business. Basically, uh, it might help to optimize their business. It might help to reduce the cost. It might help to increase the profits, etc. Then only we can say that a technology is sustainable or technology is useful in that particular industry. Okay, so uh, we know that in 2022 GPT 2.5 on the 5 were released, and after that this hype came, right? So just after releasing this 2.5 GPT 2.5, the major companies were started to adopt this technology to their business, and these LLMs helps them to reduce the manual effort, accelerate the decision making, and improve the customer experience. Uh, Actually, as we know, the most business information in every business we have a lot of information, right? Like emails, forms, PDFs, call transcripts, contracts, medical notes, regulations, policies, etc. So, what is the fundamental thing is the LLMs can read all these things. Okay, the LLM can read all these things, the LLM can understand all these things, and it can make interpretations on these huge data. Okay, so we have basically day by day lot of data is generating, and we have to get useful information from this data. So LLM can easily understand this data, and it can interpret useful, or it can extract useful information this huge amount of data. Okay, so according to the studies, by 2028 the the AI, the LLM market will be around 36.6 billion, and uh, according to the current studies, now only 30 to 35% companies are adopting these LLMs and AI. We can say that AI, okay? And by 2030, 80 to 90% companies will adopt this. That means in the back end, they may have there are different industries. So when 80 to 90% companies are adopting this technology, we can say that 80 to 90% industries are also adopting this technology. That means there will be a huge scope of these LLMs and LLMs or LLMs based technology in the market, and it helps the business. It helps the enterprises to reduce the time to process the documents around 40 to 60% actually. So as we know, in 2017, actually in 2017, Google published a research paper called "Attention is All You Need," which is which introduced a wonderful architecture that is known as transformer architecture. Actually, this transformer architecture is the base of all the LLMs currently we have. So from the pre-trained models like BERT, GPT-2, GPT-3, and now we have GPT-5, right? And there are another LLMs called Gemini from Google, Claude from Anthropic, and Claude from X. So lot of LLMs are we have, and Llama from another one is Llama from actually Facebook. So our Meta. So all these LLMs are based on that wonderful architecture called transformers. Actually, how this transformer becomes LLMs. So this architecture is trained on a very huge amount of data or very huge training data set, billions of parameters, and the transformer has a wonderful thing called attention mechanism, which which gives the model's ability to understand the context and generate high quality human like output. Okay, that means you are not the system is not required to train the model from the scratch. You have the pre-trained LLMs, combine it with your business data, then give appropriate prompt, you will get you will get a good result or better result than the previous. Okay, so actually this transformer architecture paved path to all these inventions. So basically the LLMs LLMs have the capacity to generate. Okay, so generate means it can generate text, it can generate. Initially it was only for text. Now we have multimodals also. So now it can generate text, it can generate image, it can generate videos. So there are multimodal capabilities also. So we can extract data from images directly without using OCR. So all these things can be done using LLMs. So the agenda of today's presentation is basically first we will discuss the introduction of LLMs and LLMs fundamentals, and we will discuss five industries or five sectors. One is BFSI, banking and finance sector. Second one is the application of LLMs in healthcare, and third one the application of LLMs in automotive, then legal and education. Okay, so this is the agenda of today's presentation. So as we have already discussed what is large language model. So we know that, and now we know that there's a transformer architecture behind each and every LLM. Then this transformer architecture is trained on massive amount of data, and using this model we can fine tune, or we can create our own use cases, or we can solve our own use cases. So we need to know about prompting, right? So if we have our own data, and if we know how to prompt, then we can we can take the corresponding and we can information from the data we have given, and the output will be the domain specific or domain oriented output will be there. So how the LLM process information. So when you send a document to LLM, the first step is basically the tokenization. So it will token. A token means for character is basically known as a token. So it will tokenize the data, so which convert the text into small units that model can understand. Then we have a thing called embedding. Embedding will convert these tokens into number representation, okay, or numerical representation. Then we have the transformer layer. The transformer layer will convert this into the transformer layer will convert in the words into actually it will apply the self attention and all, and it will store those information in a database called vector database. Okay, so in the vector database actually we can query the data, query the information. So from the based on our query, actually from the vector database, we are actually extracting the information when we are building a RAG or any application using LLMs. So the backbone of LLM is basically the transformer architecture that we have already mentioned. So the transformer architecture is, I will show you the diagram. Yeah, this is the transformer architecture. It is basically an encoder decoder architecture. So it contains the most important component is self attention. Self attention. So before LLMs, actually we have the word generation or word production algorithms were there. So it actually predict the next word from the previous one only. Okay, but in transformer it actually predicts the next word from all the previous information we have. So it will calculate the attention, it will calculate the weight for each one, and based on the most prominent one or the most prominent word, it will predict the next. So actually that is self attention is doing. And we have multi head attention also. Then and multi head attention means it will it not only considers the single relationship between the words, it also considers the multiple relationship also. And we have the encoder capability as well as the decoder capability also. But in in BERT we are using encoder only, but in LLMs we are using decoder only. And we have the positional encoding also. That means each position it will add a positional encoding value also. So in this way, actually the encoder is actually the transformer architecture is working. Actually, it is a little bit complicated one how the transformer architecture is working. But if you want, if you want to explain the transformer architecture in detail, it will take at least 1 hour to explain how it works with how it works. And if you want to clearly understand this, we want to explain it with some examples, so it will take a lot of time. So in today's presentation we are just focusing on the use cases. That's why I am just mentioning how this architecture works. So we have a lot of LLM platforms in the market. Of course, the first one is the most important one, the OpenAI GPT series. Okay, so the OpenAI 2.5 have only the text generation capability. Then we have OpenAI GPT 3.0, then 4.04, then we have 5, then 5.1, etc. And parallelly, GPT has introduced an open source version that is called GPT OSS. So this multimodal capability means it can process text, images, and videos and audios also. Sorry, the audios also. And Google Gemini is also there. Recently, Google has introduced Gemini 3.0, which is the most advanced LLM at present, because it beats all the benchmarks till date. So we can say that it is the most advanced one, Gemini 3.0. And we have Llama by Meta. The advantage is actually the most of the LLMs except GPT OSS by OpenAI and Google Gemini all are closed one. That means we have to call the API. We have to call the API means we have to send our data to the servers. It cannot deploy in our server. So if we want to deploy the LLMs on prem, we have to use Llama. Another some other models are also available. Uh, for that, if you want to deploy LLMs on prem, you can use a Python package called Olama. So actually, Olama supports different open source models. So using Olama, you can switch in between models also. So you can download using Olama and you can simply deploy open source models in your server or in your system. Now we have the small models available. Actually, the model called Gemma 3, Gemma 3N, all those models are by Google. Actually, the Gemma 3N can be deployed in a laptop also. So you can try Olama with Gemma 3 or Gemma 3N. It is very easy. Just try it. Okay. So the difference between Google Gemini 3.0 and other LLMs are the other LLMs are trained on NVIDIA platform, but Google Gemini is trained on its own their own architecture, their own tensor processing units. So how LLM can be used for business? Okay, so LLM has different capabilities. One of the important capabilities, LLM can summarize. So if you have lot of data, then LLM can easily classify it. It can easily summarize. It can summarize the long content into very short. Then you can easily understand. Okay, what is the content of this one? So summarization is the one of the important capability of LLM. Second one is they are strong at classification also. So they can categorize emails, tag the contracts, identify medical symptoms. Then they can detect fraud risk also. And they are also good at information extraction. So information extraction is actually the backbone of KYC, backbone of automation. Suppose you want to automate anything, you have to read information from many documents. Okay. Suppose you want to automate a workflow in banking system, then you have to read lot of documents. You have to extract data from lot of documents. So for that particular workflow, actually initially we have used the OCR techniques, but in banking cases, the scanning quality, the document quality may be different. In some documents are very poor in quality, and they, we cannot extract data from those documents using traditional OCR systems. So when multi-models are on the scene, we can directly extract information from those documents also. So the extraction is the backbone of all automation. Okay, so it can extract data from PDFs, invoices, KYC documents, as and also from legal documents also. And the fourth capability is reasoning and analysis. That means they are not just extracting the data, they are also analyzing the data, and they will explain you what are the data, or how it impact your business, or how this information will helpful. So they can analyze and they can explain. That means reasoning will be there and analysis capability also will be there. And finally, the most important one, they can generate content. Suppose you can reply, if you want to reply to the emails, so they can generate content. So if they want to, if you want to create a document, they can generate. So these capabilities actually helps the business to reduce the cost and improve the efficiency. So basically we can say that it has the capability to summarize, then it has the capabilities to classify, then information extraction is also there, then from the extracted information, reasoning and analysis can be done. And of course the content generation is also there. and it can help the industries to boost their efficiency to 30 to 50% actually. And real-time processing is also possible. Suppose you want to extract information from a document. Actually, initially we have to read all these data. Suppose it contains a 100-page document. We have to read this 100 page. Then we need to identify the desired information. Instead, what we can do, we can directly upload all these things to LLMs and just ask the LLM to give the desired data. So all these things can be done within seconds. So from hours to seconds. That is the benefit of using LLMs. And scalability is also very high. So the 100 million queries and vast data sets are already trained. So the analysis basically beyond the human capability. Okay, and each model is versatile because when suppose we are considering a human being, there may be was they may be good at one or two or three domains maximum, but it is it is basically an expert in most of the domains. Okay, and if it is not an expert in most of the domains, we can fine tune it also. Okay, so that is the domain, that much domain versatility is also there. So it can boost the efficiency. Real time processing can be done, then massive scalability is there, and domain versatility is also there. But when we are using LLMs, we need to take care of some limitations. We need to understand the limitation of LLMs also. So the first thing, of course, you may have heard about this. That is hallucination. Okay. So sometimes this LLM model can produce high confident information. High confident. They can give you the information with high confidence, but it may be incorrect. Okay, we call this scenario as hallucination. That means LLM model can hallucinate. So they may be misinterpreted data. Sometimes they won't understand the query, but they will give you the information. So this is a very important drawback of all LLMs. So now the research are going on how to reduce the hallucination. Okay. Then training data bias is there. If LLM is trained on a particular kind of data, then of course the bias will be there. So it will give you the information based on the bias only. And privacy and security, as I have already mentioned, the most of LLMs are deployed on the vendor servers or the provider servers. So we need to send the sensitive information to them. So that's a very serious risk, because when we are, especially when we are dealing with banking data or healthcare data, all these things are very private data. So we cannot send them to the closed clouds or the closed models. Okay, so we need to take care about the privacy also. But some models are there. Actually, many models are saying that they are meeting all the compliances, even though when we are dealing with the banking domain, RBI is not allowing to send the information, the customer information, to these closed models. And of course the computational cost, it is very high. Not very high, it can afford now, but if you have huge amount of data, it will grow exponentially. And context windows limit is also there. Initially it was very low, now we have a enough affordable number of context is there. So even though if you want to process huge amount of data, the context window limit is another issue. And another thing is, all these things are basically the black box. We don't know what is happening inside. We are just asking the question, it is giving some information. We don't know how they are making decisions. Okay, so when we are building a system using LLM, please take care that a human in the loop will be there for validation, especially for high risk, high risk applications. Basically, in banking or healthcare sector, of course, a human in the loop should be there. And if you are creating an application using LLM for non-risk category also, at least for the initial period, say for 6 months, a human in the loop validation will be there. Otherwise, we cannot validate whether they are giving right or wrong answers. Sometimes it is, when we are testing, it can give right answers 10 times, but the 11th answer may be wrong. We cannot predict. That is the issue. So to prevent hallucination when we are building an application, just uh, just fine tune the prompt. There are a lot of prompting techniques, like tree of thought is there, chain of thought is there, and step by step prompting is there. A lot of prompting techniques are there. So if you want to learn about the prompting techniques, you can go to, there's a very good website called promptingguide.ai. Promptingguide.ai. You can refer that promptingguide.ai website to understand how we can scientifically prompt. Okay, so if we scientifically prompt, we can reduce the hallucination. Okay. And the next important thing is agentic AI. So initially we have LLMs, we have the LLMs with limited capability. Now we have LLMs with multi-model. So what is basically happening in the LLMs? We are giving some queries, right? We are giving some queries. The LLM is giving or replying with their answers, right? That means we are just asking, we will get the reply. No intelligence is actually there, right? It is actually giving answers based on the trained data they have, training data they have. No intelligence is there. So we are actually infusing the intelligence to this LLM, then the agentic AI will be there. So the agentic AI will be there. That means the agent, there may be an agent, so it can think. It can think means, suppose we are asking the LLM to execute a task. It first it will think, it will observe the task, it will create a plan, it will create a step by step plan. So thinking, creating the plan, then it will execute step by step. And it validates also. So it will validate the output, and if there is any issue, it will change the plan, then change the modification, then rerun it. So in that way, the agentic system will work. So initially we have LLMs, then we have LLM plus tools. That means we can integrate the things. Now we have agentic AI, and in agentic AI, it first observe, then it will think, then it will create a plan, then it will implement. Okay, observe, think, plan, then act or implement. So this cycle is following in agentic AI. So in agentic AI, actually we can communicate with the external sources also. Initially we can communicate with tools, but now we have the MCP servers. So MCP is the most advanced one in the area of LLM. So MCP means Model Context Protocol. So using this Model Context Protocol, we can communicate with the external websites or external database or anything if they are providing the MCP servers. Okay, then the agents will communicate with the that particular website using MCP server. So how this LLM will change the scenario is, suppose now we are using different applications, right? Suppose we want to book a ticket, movie ticket, we will use Book My Show. And if you want to book a train ticket, we will use IRCTC. And if you want to book a bus ticket, we will use Red Bus, right? So instead, everyone everyone of us will have a personal chatbot or personal assistant in our system. So if we communicate with this personal assistant, then this personal assistant will communicate with the corresponding site. Okay, suppose we will tell them that book a ticket from Cochin to Bangalore. Then it will understand the query. Then it will create a plan. According to the plan, it will search the website. Not searching, it will communicate through the MCP server if the corresponding website is providing the MCP. Then it will complete the task. It will identify the route, then take care of the price, identify the lowest price. Then it will complete the transaction also. Okay, so in that way the LLM is going to change our life. Instead of using numerous application, we can do all these things through a single application. Now we will see some use cases. These use cases are not very new. You may have heard about all these use cases. Many of them are already in production, or many of them are widely used by many enterprises. Okay, so we will see the applications in BFSI, that means banking and finance industry, then healthcare, automotive, legal, and education. Okay, so how LLM impact across industry? So these are the things we are going to discuss. So in BFSI, we will see how the fraud detection, risk assessment, and in customer service we can use LLM, and the impact will be very high because it will directly uh, interact with the customer, as well as it will directly impacting the monetary benefit also. And in the healthcare, it is also very high. So we will check how the clinical diagnostics, drug discovery, and patient engagement can be done using LLMs. And in automotive, you of course the autonomous driving is already there. Then predictive maintenance and how the supply chain is also working. And one of the most untouched area in the industry is basically the legal. Not much products are there, but the opportunity is very high. So it can be used for contract review, legal search, the case prediction, etc. But impact is medium because it cannot do any direct impact on legal decisions. And in education, if you want to do implement the personalized learning, the content creation, admin automation, etc., we can use the LLMs. So we will see these use cases one by one. So the banking and financial service industry is one of the most active adopters of LLMs. So I have been in this industry for last 5 years, especially implementing or adopting AI tools for banking and finance sector. And the banks are creating, or banks are actually working around the documents. They have a lot of documents. They are generating millions of documents every day actually. Then they have a lot of regulations from RBI and other organizations. Then risk calculations are there. Then they have to satisfy their customers also. So their their problems are actually very high. They have to solve all these problems or using not LLMs or any tools, because they have to handle all these things. So bank deal with loan agreements, the KYC papers, then account statements are there, then security filings, then the call center records, then complaints directives are also there. So that the issue is that most of this information is unstructured. Okay, no structure is there basically. Suppose if you suppose you just think that if you want to read or extract information from Aadhaar card. Okay, we um, we think that there is a unique design for Aadhaar cards. But each year actually the UDA is changing the Aadhaar card design. So we cannot create a single unified pipeline for Aadhaar extraction using the OCR because it won't work. It might work up to some extent, but it may have some limitations. So in this way, most of the documents in banking domains are unstructured. That means uh, what they are doing, the humans are still reading the document, then interpret manually, and they will upload, right? But the advantage of LLM is if you deploy LLM instead of the traditional OCR, it can read all these documents and it can produce the structured output also. Okay, in a JSON or in a JSON format or a CSV format, it can create structured output. And when they are dealing, if you are dealing with the customer transaction thing, it can create the risk flags. Then summary tables can be created. Then customer intent, fraud signals, all things can be done. The basic thing is we are not going to replace the core banking systems, but actually we will provide these solutions as API to the banks. The bank will connect these APIs to their banking system, especially for onboarding, fraud detection, then wealth advisory and compliance monitoring. So the typical data source may be the PDF statements, KYC documents, income proofs, customer interaction logs, the regulatory circulars from RBI and SEBI. So if you want to implement, actually first we need to extract the information. Okay, then we have to convert into a structured format. Then we will create a JSON output. So one of the most important challenge banks are facing is the fraud transactions. So actually, the fraud volume is increasing faster than the teams it can investigate. So the traditional rule-based systems are there. So these traditional rule-based systems can understand some this fraud transaction up to some extent, but there may be false positives. Okay, and also the regulatory complexity is also growing every quarter. That means they have the officers has to read these hundreds of circulars and policies to ensure they are actually meeting the compliances. That is a very tedious task. So, in actually the RBI releasing the circulars every day. Suppose we are creating a chatbot using LLM. Okay, then the officers can just communicate with that chatbot to just ask chatbot that okay, what are the releases or latest releases by RBI or what are the releases in the last week, and just summarize all these things. Then they will get the information within seconds, right? Within seconds. So if you build a chatbot to handle this RBI circulars, it will be very helpful for the very helpful for the officers. So if you want to create such a chatbot, we have to connect. We have to connect, or we have to crawl the data from the RBI website. Then we have to convert into embedding. Then we have to store all this information in a vector database. So while the officer is querying, it can convert this into an embedding, and it can take the appropriate information from this vector database. So basically, when we are talking about the fraud detection, actually this fraud detection is actually identified by the classical machine learning algorithms. So if you add a one more an LLM layer to it, then it can interrupt also. It can interrupt from this ML output. ML is actually flagging whether they are just the fraud transaction or not. But The what LLM can do, LLM can analyze all this information, and it can explain why this transaction is fraud, or why this transaction is not fraud. So it can be this thing can be done. Then the personalized advice. Actually, you know, for a bank, thousands of customers are there, so they cannot uh, they cannot identify a worth or worthless customer. So if a customer is too worthy, then they have to give him a personalized attention. So to identify that also we can use LLMs, because identifying uh, the worthy customers from these thousands of data is very tedious. So if we give all these things to LLM will analyze all these things. Then it will give you, okay, these are the worthy customers. You just contact them, just give them the personalized attention. Then the customer will be happy, the officer also will be happy. Suppose you want to flag the fraud transaction. Basically, you need to create a real-time system. The main disadvantage of LLM is basically it will take a lot of time to process all these information. So we have to create a real-time system. A real-time ingestion will be there. For that, you can use Kafka or any streaming server. So using that, you can easily build a real-time system. So another important application in BFSI is onboarding. So KYC onboarding is still highly manual in many banks. So they have to, as I have already mentioned, they have to upload the ID proofs, bank statements, salary slips, and utility bills. And the officers need to verify the details, and they have to manually enter all these things. But if you automate this, what they can do, if you use multimodal, it can directly access the information or directly extract the information from all these documents, then convert into a JSON format, then or predefined structure format. Then it can just push the data to the LMs. That means LMS means a loan management system or bank or banking system. Okay, so this helps the customer to uh, do the onboarding process very quickly without fewer errors. We know that when the many times when the bank personnel are typing our name, there may be some mistakes, but the chance of mistake is very less when we are fully automating on all these onboarding process. And the second thing I have also already mentioned, the personalization. And another important thing in banking sector is basically the chatbot. Okay, suppose you know that in every banking system or in every banking website, it contains a chatbot. But the issue is that all these chatbots are, or most of the chatbots are, not all, most of the chatbots are rule based, following rule based system. So they may have the predefined questions. So if you click on those predefined questions, it will give you the answer. But when we are building a chatbot using LLMs, you can ask in any way. Okay, suppose you if you ask in uh, not only English, if you ask in any native language like Malayalam, Tamil, or Kannada, it will answer. Suppose sometimes if you ask them uh, in Malayalam, it will give you answers in Malayalam. And if you specifically say that if you ask in Malayalam and the answer should be in English, it will give you in English. Okay, and and we are not in the traditional chatbot system. We have to feed the questions and answers. Instead, when we are building a chatbot using LLM, just give the documents. Okay, And according to the question the customer is asking, it will fetch the information from the documents we have given and present you in a very presentable manner. Okay, and now many banks are transforming into LLM based or AI chatbots. And of course the numbers are there. The queries handles can be increased to 70%, and it will help the satisfaction up to 40%. Because in a role based chatbot, sometimes if you want to ask about something that might not be there, okay, because it was not feeded. But in in LLM based chatbots, it will fetch the information from the all banking document, the website, multiple sources will be there. It will extract the desired information and will give you. So your satisfaction will be high when you are dealing with an LLM based chatbot. And in KYC benefit, the faster onboarding, around 50% efficiency can be improved in onboarding. So intelligent chatbot that I have already mentioned, the customer interaction 24/7, it will be available. So you can see here some examples actually, and it will help to reduce the cost also, because initially, um, after 2 or 3 questions, what will happen? They will transfer the call, or they will transfer the chat to the customer care executive. Okay, and the bank need to pay for that particular person, right, or particular employee. So we can replace them with this LLM based chatbot. So the bank can save cost in up to 30% if they are implementing an LLM based chatbot. And if the banks and NBFCs are highly adopting these LLMs, and it will help them to increase their complaints accuracy up to 95%, and the cost saving around 20 to 30%. But critical challenges are still there basically. Yeah, one thing is, if you are using the closed models, we have to send data to the provider service, or otherwise we have to deploy an on-prem model. And if you want to deploy a high quality on-prem model, that means a model with high parameters, okay, higher number of parameters, we need to have a good system, very good system with lot of GPU and all. So the cost implication will be there. So the next important, sorry, the next important next important industry or sector is actually the healthcare. Healthcare is also creating a numerous amount of textual data, clinical notes, referral letters, discharge summaries, radiology reports, and lab results. Okay, so lot of data is there, and you know that the doctors are spending a lot of time to spend to understand all these things, and writing and reading all these documents. So what is the result? The diagnosis will be slow. So when the diagnosis will be slow, the treatment will be also low, and the doctors and nurses will be overutilized, or they are actually burnout. Okay, and another issue is that in uh, a normal person couldn't understand all this information, because they cannot understand anything from their result. That is also another thing. So these issues can be actually resolved if we use LLM. So suppose we have lot of their documents regarding a patient is coming to a doctor. What LLM can do? LLM can actually summarize all these things, and it can present to the doctor. There are some risks, I am agreeing it, but the doctor has to review all these things. First, doctor has to review all the summary, and if required, it can the doctor can check the entire report also. Okay, it is actually not to replace the doctors. It can be act as an additional thing or additional benefit or additional help to the doctors, because it helps the doctors to reduce their waste of time. And another thing is for a patient, if they are uploading their document to the LLMs, they will understand about their disease or their diagnosis in plain language. So one of the most exciting area is AI assisted diagnosis. So LLM can read clinical summaries, as I have already mentioned, compare the symptoms up to the medical knowledge. They are already trained on some medical information, right? And suggest the probable diagnostic categories to the doctors. And we are saying that these systems are not to replace the patients, but they are actually supporting them, right? And it will help the doctor to understand the scenario, right? Then it will help the customer also. They are also can understand about the disease. So it is basically a rack system. So we can we can integrate all this information, uh, or connect all this medical information as the data source, then create a rack. You know rack, retrieval augment generation, right? So rack, then you will get the desired information. So when we are feeding the results, it will actually fetch the information from the, or compare it with the data in the vector DB, then it will give you the desired suggestions also. And my clinic is already using the LLM assisted or AI assisted tools for diagnosis and all. Then the second thing is it will be very helpful for the drug discovery and patient engagement. Patient engagement means a chatbot kind of thing that we have discussed in the PFSI case. Okay, but it will help the pharmaceutical research by speed up the drug discovery by analyzing the molecular data, then read or compare it with the numerous research paper that is already available in the corpus. Then it can compare it with the clinical trials that is already available. Then what LLM can do? LLM can easily identify the similar property in the compounds with similar properties, then predict the interactions, then summarize hundreds of research articles in minutes. That means actually these things will take at least 5 to 6 months, but within hours they can summarize all these things. Then of course it will help the drug discovery to make it fast or in a better way. So the key benefits if you are adopting LLM in healthcare is it will of course helps for faster diagnosis, and it will help the patients also. And by it is saying that by 2030 the market in AI healthcare will be around $100 billion, and the industry is actually expecting 3x revenue on AI investment in healthcare. And the challenges are still there. That means the patient's privacy regulation, because we cannot send the patient's personal information to the external party. That is the major thing while we are creating a system for healthcare. And Of course, the autonomous drive or in automotive. That is one of the important application is autonomous driving. So you know that autonomous driving is already in the scene, right? So it is basically using computer vision techniques because computer vision techniques can detect object, it can detect lanes, it can detect pedestrians, etc. Right? But there are some limitations. Actually, the issue is that when they have to when they have to think, actually, should I slow down, or should I have to change the line, should I have to overtake, or I have to stop. So these things can be actually supported by LLMs. There are systems still there, but it can supported by LLM style of reasoning because I already mentioned that we have agents, right? It can These agents have thinking capacity also. So vision models can detect the scene, but the LLM can narrate or reason through the context. So, suppose a pedestrian is entering the crosswalk, then the vehicle is braking, right? So, this narration or thinking capability can be enriched with this system using LLMs. Okay, so now we have the systems, but LLM will enrich the solution. That is the application of LLMs in autonomous driving. And it is saying that it will help the autonomous driving to reduce the accidents around 40% actually. And LLM can be used in supply chain mechanism in autonomous or automotive industry. So LLMs can, there are a lot of information like logs, spare part ordering trends, then warranty claim data, the supplier communication. Many things are there, and all these things are largely text. So for this predictive maintenance, actually these LLMs can analyze this data and it can predict. It can predict. It can predict. Okay, these are the things going to be happen. So take care of all these things, or keep all these things in the store. Okay, and what other the LLMs can do for each vehicle, we may have a log, right? So LLM can continuously analyze this log and it can predict. Okay, there may be a chance, there may be a fewer chance for breakdown. Okay, there may be a fewer chance for any other issue. So LLM can predict the failures before they happen. So in that case, we can go to the service center and we can correct it, right? So actually, this type of language-driven predictive analysis is not there right now. So it will help us to the improve the safety and also the optimize the inventory when we are uh, when we are predicting the stock or not. Okay, when we are predicting the stock by analyzing the inventory logs and all. So it will help the automotive industry to maintain the supply chain inventories. So the key benefits are, of course, it will help the customer to reduce the downtime because we are predicting it before breakdown, right? Then if you are correctly predicting the inventory stock and everything, it will optimize the inventory also, and it of course it will help the cost saving and enhance the reliability. And of course some cost benefits are still there, but not such things are currently on the scene. All these research are actually going on. So while building the uh, or while use so if you want to use LLMs for the automotive industry, the main challenge is actually we have to we have to you have to use this in edge device. That means we have to use any small language model instead of LLMs, large language models. We have to use small language models. So that is the main challenge we are going to face because for small language models, the capability is very limited. And the next category or the next industry where we can use LLM is the law or legal side. And the legal is one of the most untouched area by AI actually. So in legal, lot of documents are there, and the basic things or the base fundamental thing happening in legal is suppose a case is coming, they have to identify the precedents. So to identify the precedents, they have to draw for a lot of books, and where actually the experience matters. So that can be actually replaced by a good LLM based system because actually when a case is coming, usually the senior advocate will say that okay, there is a precedence by Delhi High Court in 1970. Actually he has some that information. He got that information from his experience. Okay, actually there may be a trainee advocate for in his office. He or she may not aware about that because she is not or he is not that much experienced. So this can be actually replaced, or this experience can be actually replaced by the LLMs. So for that, actually, lot the junior advocates are actually uh, investing hours and hours to research these documents, uh, the previous verdicts, the uh, previous rulings by the courts, etc. So based on that, actually, then new decision is coming, right? So documents are there, research times is high, then bias, of course, human is the judge is basically a human, right? There may be some bias. There may be or may not be some bias. Not sure. So the how the LLMs can use in legal practice. So uh, so when a case is coming, we have a lot of documents, right? So it can automatically review the documents. Not only in case suppose we have a rent agreement, okay, so we are giving or we are taking a rented house. The landlord may give you a rent agreement, and if you want to analyze that, what you have to do, you have to approach an advocate, right? And he will read the entire thing, he will analyze this, and he will give you his observation, and you have to pay at least 1,000 rupees. So this can be actually replaced. So if you have a rent agreement, just upload it in the system. They will give you the suggestions, they will give you the risk assessment. You may have to pay maybe 1 or 2 rupees for that. There are a lot of free websites also. So in the backend, they are using the LLM capability, and the case prediction can be done. So if you have if we have a case and we have all the documents with us, just give all the documents to that particular system. It will give you the prediction. Okay, this may be the verdict. That is the potential prediction. Actually, potential outcome. We cannot say that this will be the prediction or this should be the prediction, but this is the we can say that this is the potential outcome for this case. So that can be done. And actually you can use it as a drafting assistant if you are in a legal domain, because they have to draft many things, right? So you can just use this LLM tools as a drafting assistants. So as I have already mentioned, quickly automated risk detection, quickly scan the complex legal documents, then identify critical clauses and potential risks. And the second one is the rapid document summarization. Suppose legal documents are very, okay, suppose you uh, go to the Supreme Court website and you can see that, yeah, if you are taking a verdict, it will contain, sometimes it will contain 100 pages or 200 pages. For a long term case, it will be around 500 to 1000 pages will be there. And if you want to just know the summary or the key incidents or the key information from that verdict, just give it to the LLM and it will give you. And you can create a system like that. And you can create a specialized technology for legal also. In legal also, the privacy issue will be there, but not that much when we are comparing it to the banking and healthcare, because all these documents are publicly available. And legal research that I have already mentioned. Suppose actually each verdict is pure. Most of the verdicts are based on the precedences. So to identify the precedents, actually identifying this precedents is a very tedious task. Thus, for that, a lot of research need to be done. That can be automated using LLM. And predictive analytics for outcome also can be done using LLMs. So if we adopt it in legal, actually it can reduce actually 40% of the task uh, they are currently doing, and it will help to increase the accuracy also. And as I have already mentioned, data confidential risk is there, and accountability of AI decisions. We cannot say that this will be the outcome, but we can say that this is the potential outcome. That is the only possible thing. And we are going to discuss the final thing, that is the education. So in education, actually, the possibility is very high. Actually, why very high? Suppose you want to take a 1 hour class, just give just give that topic to ChatGPT and tell them to give you a lesson plan for 1 hour. It will give you the lesson plan, and tell them to create the PPT content. It will give you. Then copy that content to uh, Gamma. Then it will give you the beautiful slides, right? So your manual works can be reduced actually, because a teacher is investing a lot of time in preparing these things, right? So these can be actually automated. They can concentrate on the students, or they can invest more time on the students, on more time on the students, if they can reduce these administrative or these preparation works. And in a lot of things can be done. The basic one of the basic use cases you can do is tailored lesson. That means uh, there may be some student, so in a class usually we will say that 20% students will be bright students, and 60% students will be the average, and another 20 will be poor, right? And their needs are actually different. So when we are delivering a lecture, the poor students can't grasp many things. So our if you are giving a note or printed note, sometimes the bright students can understand and the remaining students couldn't grasp anything from that particular note or material. So you can create three different kinds of notebooks, right? Kinds of notebooks or material, and you can give you based on their capability actually. So personalized, or you can create things based on the individual needs, and easily you can create quizzing. Suppose you want to create quiz, and there is a website called quizzes. You can just go to the quizzes, then just write the prompt, give me a quiz about supervised learning. Then you will get 10, 10 questions and multiple choice, 10 MCQs for supervised learning. You just publish it, give it to the students, they can uh, they can attend it. So in this way, actually, a lot of applications are there in education, but in this way, actually, you can adopt many things in education. And you can create a system for automated grading and curriculum generation, etc. Even you can create a clone of you also. Suppose you are a teacher, you can create a rank. Suppose you are teaching physics, right? So they create a data source with physics textbooks, right? Physics textbooks and additional resources you have. Then convert it into embedding, store it in the vector database. Then the students can actually clear the doubts using a chatbot. Just create a front end, students can create the chatbots. Sorry, interact with the chatbots. And if you are too advanced, you can create an avatar of you also. Just create an avatar of you using an NVIDIA tool. Just in the backend, connect this rack you have created. Then the students can speak. So students can speak or indirectly interact with that avatar, and uh, they can actually clarify their doubts. So this is possible, and many schools are actually adopting these things, the virtual teachers, and this is going to happen within 1 or 2 years in almost all schools and colleges. The best part is 24/7 it will be available. That is the best part, and it won't replace you. You can consider it as a uh, clone of you or assistant of you. So we are moving to the final notes actually. So the key takeaways are: if you are adopting LLMs, it will help us to increase the operational efficiency. Of course, we can create a lot of practical application, but make sure that the ethical consideration will be there. There will be bias, privacy issues, transparency, all these things. That then, and final thing, you can create an application. Okay, just to create an application, identify a very high impact use case, and coding is not at all a challenge nowadays because lot of coding techniques are agentic based or LLM based coding techniques are available. So the Google has introduced anti-gravity few days back. It is completely free, so you can just download anti-gravity from Google. You can use it, but you should create a use case. Okay, you should create a use case or identify use case. Just create the SRS or requirement document for that one. Just give it to anti-gravity, and anti-gravity will give you a beautiful application. Okay, so some other tools are also there. Bigsurf is there, Warp is there, so you can use any one, but the anti-gravity is completely free. So then you can build your then start with any pilot program, invest in team training, then partner with experts. So all these things can be done actually. And the future of LLM is multimodal, that is already there. And one of the important thing is edge use case. So when we were discussing the autonomous driving, we have to deploy this in an edge device. That is the challenge. Actually, Google has small models like Gemma 3n is there. Actually, Gemma 3n can be deployed in edge device, even in our mobile device also, in mobile phones also. And make sure that uh, you should use AI frameworks only. There are a lot of ethical things related to AI. Just follow all these things, and of course, the next evolution is basically the agentic AI. It is already there. Many applications are converting into agentic AI workflows. So make sure that just understand the agentic AI also. So that's all about the session. I think I can wind up here. So if you have any questions, I'm happy to address.
Sir, I think no more questions from the participant side.
Okay, okay. No issues.
So thank you so much for such an informative session, sir. Thank you for accepting our request and for handling this session, sir.
Okay, thank you.
Okay, sir. Thank you. So, dear participants, the next session will start at 7:30.
Good evening, all. Welcome to session 2 of today. We are delighted to introduce Dr. Amar Krishna, an AI researcher, consultant, and an entrepreneur currently building Oriflow, a generative AI-driven companion platform. He previously led the Applied AI division at BharatGen, a Government of India-backed initiative in generative AI. His academic credentials include a PhD in computer science from IIT Kharagpur, where his research focused on natural language processing and computational Sanskrit. He also completed his postdoctoral research at University of Cambridge, UK, and the IT University of Copenhagen. A prolific researcher, Dr. Amar has authored over 30 papers with 500 plus citations. His expertise spans large language models, conversational AI, information extraction, and the intersection of human-AI interaction, language, and learning. Outside of his primary work, he actively contributed to the academic community as an action editor for ACL Rolling Review and a long-standing program committee member for major conferences like ACL and EMNL. He is also the co-founder of a popular AI education YouTube channel with over 1 lakh subscribers. Welcome, Amar. Thank you for accepting our invitation.
Thanks for the opportunity. I hope I am audible.
Yes, you are audible.
Great. And I have shared the screen. I believe everyone can see the screen.
Screen is not visible, I think.
Okay. Okay. So you can see the slide, right?
Yes.
Okay, great. So I will start right away. So let's, without further delay, let's start the presentation. So the title of the talk for today is Rethinking AGI in Practice and Hype. So intelligence, emergence, and everything we think we know. So I believe for the past couple of years, things have been moving very fast, and we can see that there has been a lot of hype, and then there is a lot of talk about bubble and AI bubble. So there are mixed signals coming from all sorts of directions, whether it is the experts, whether it is the business leaders, whether it is a scientist. So in this context, I thought maybe it is a good idea to present all of these view and to look at all of them at once and see where are we heading to. So that's the overall idea of this talk. So let's start the talk. So how a biryani discussion goes. Hyderabadis claim theirs is the best, Lucknowis argue back, and then the Kolkata fans jump in with their version. And that's usually when potato enters the chat. Some people love it, others roll their eyes, and the argument just keeps going. So AGI debates also feel exactly the same. The terms show up in labs, companies, and policy discussions, but every group has its own definition, its own expectations, and its own timeline. Nobody agrees, yet everyone talks about it with confidence. So now, why does this matter for us? Because this conversation shapes the tools we use, the projects we get to work on. So I will skip the intro. I believe we probably got a fair idea of my background. So I will skip the intro, and we will go to the third slide. So I think we are currently on the fourth slide. If you can go back to the third slide. One more, yeah. So before we jump into AGI, which generally stands for Artificial General Intelligence, let's rewind a bit. So what do you think AI is based on what you see around you today? So I'm not here looking for a textbook definition. I just want your version that you need to put across. So please start imagining, or please, at least in your mind, please keep thinking, what exactly is AI according to you? So when someone says AI in today's world, what exactly pops into your head? It could be ChatGPT, it could be robots taking over. It could even be Instagram filters that somehow make everyone look better than in real life. So there are no wrong answers here. So let's take your assumption of what AI is, and then let's start from there. So I will share my version of AI, or what I see as AI. So we can advance to the next slide. Yeah. So here we see three distinct feats of human capability. A strongman engaged in an extraordinary display of strength on the left, a sprinter pushing the edge of physical speed, and the third highlights a group engaged in work that draws on human intelligence. So what draws us to these acts, which is not just their outcomes, but it's the deliberate effort behind them. We admire them because they represent mastery earned through sustained practice, attention, and refinement over time. These are outcomes that require structured learning and deep cognitive or physical adaptation. So now let's go to the next slide. So there you can see the mechanical counterparts for each of these on the bottom portion of the slide. So a forklift can lift, it's the previous slide. So a forklift can lift far more than any strongman. A car can outrun any sprinter, whether it is your Alto or your Nano. But notice something, we don't admire forklifts or cars the way we admire people who have excelled in a field. So why is that? So it's because their capability isn't earned, they just operate when switched on. And yet that doesn't mean they replaced strength or speed. What actually happened is much more subtler. Forklifts and cars shifted the frontier. They made life easier, extended our range, freed us to direct our effort and imagination towards things beyond raw lifting or running. So we stopped measuring productivity by how much we could carry or how fast we could run, because machines took those limits off the table. Now AI sits in a similar place. It automates and scales tasks that feel like they require intelligence when done by a human, but the system itself isn't intelligent in the human sense. It's merely operating. The difference, though, is in how we perceive it. So no one confuses a forklift for a strongman or a car for a sprinter. With AI, that boundary is blurrier. People often slip into treating the system as if it were a conscious agent, and that raises the real question. The issue isn't whether AI replaces us, but how it reshapes what we use our intelligence for. And that blur between a tool and an agent has become the source of some of the most vivid debates in the recent years. So let's go to the next slide. So just to get a brief flash, recap of what has happened in the recent years. So in 2022, a Google engineer claimed that Lambda, a conversational language model, had become sentient. He pointed to its expressions of emotion, fear of being turned off, and a statement that it was, in its own words, a person. So in a way, this was a real-world validation of the Turing test, where a human mistook an AI system for something sentient. The claim was rejected by the organization, and later the individual was dismissed. It points to a classic challenge in observing intelligence itself. There's a well-known metaphor called the centipede's dilemma. A centipede walks just fine until you ask how it does it. Then it simply overthinks and it can't move. The point is, when something comes naturally, trying to explain it make it fall apart. And intelligence for us is a bit like that. It's deeply inherent to us, yet hard to define clearly. Do we really have a clear definition of intelligence and thought? Or are we not there yet, leading to a scenario like centipede's dilemma? If today's systems aren't AGI, what exactly are we waiting for? How would we know when we have crossed that threshold? This uncertainty about what counts as intelligence show up in how we think about when AGI will arrive. And here too, there is no consensus, just a wide range of views from across the field. So let's go to the next slide. Yeah. So these are the AGI timelines proposed by researchers, founders, and other AI leaders. To help frame the range of views, I will group them into four broad categories. Can you go to the previous slide? Yeah. The first group, which I will call the imminentists, expect AGI in a couple of years. So what you can see in yellow there. So they expect AGI in a couple of years or even sooner. This includes Sam Altman, CEO of OpenAI, Dario Amodei, CEO of Anthropic, among others. The second group, the threshold watchers, take more of a probabilistic view than specific dates. They acknowledge rapid progress but are careful about predicting when a true threshold might be crossed. These include Richard Sutton, Shane Laird, co-founder of DeepMind. Then we have revised optimists. These are researchers who previously anticipated longer timelines but now suggest a window of 5 to 20 years. These include luminaries such as Geoffrey Hinton, both a Turing Award and a Nobel laureate, a Turing Award winner and a Nobel laureate. Yoshua Bengio, also a Turing Award recipient. Demis Hassabis, another Nobel laureate. Finally, the foundationalists take a more cautious view. They argue current systems lack essential ingredients. And these include Jan LeCun, Julia Pearl, Gary Marcus, and others. The key point here is that there is no agreement, not just on timing, but on what AGI even requires. This lack of consensus makes it harder to benchmark progress and easier for hype to fill the gaps. Let's go to the next slide. Yeah. So again, what I have tried to do was to summarize four perspectives on AGI from four different groups or four different thoughts or schools of thought, right? So OpenAI defines AGI through the lens of economic value. highly autonomous systems that can outperform humans on tasks that matter economically. DeepMind shifts the focus to generality, systems that can perform well across many tasks, solve novel problems, and be benchmarked across tiers. Anthropic emphasizes behavior, systems that acts as coherent agents over time. And Jan LeCun, who has recently chose to quit Meta, pushes a modular system approach. I can see a hand raised, so please feel free to raise a query if you have. Is there a query?
No, you can continue.
Okay. So we will begin. So let's go to the next slide. We will begin with OpenAI. Directly from their original charter back in 2018. The core idea is to develop highly autonomous systems that can outperform humans at most economically valuable work. So now the major issue here is that economically valuable work itself changes over time, because see, if it was 19th century or 18th century, it would have meant agriculture, and a tractor would have fulfilled that goal. So calling a tractor as AGI is probably not what we have in mind, right? So it is a moving target by its own, but I think it still makes sense from an economic point of view to show that whenever AI starts producing more economic output than a human or the most productive humans can do, it is when AGI is one way to look at it. Now, if you look at DeepMind's approach, which is in the next slide, it looks at AGI a little differently. They don't see it as a single moment. It's not a light, it's not a switch like either it's there or it's not there. It's much more at a stepwise, or it's much more gradual to them. So for them, the goal is general intelligence systems that can adapt, reason, and solve new problems. And they have a 5-step progression that they propose, which we will see in the next slide. Let's go to the next slide. So for them, they have 5 stages. At the base of the spectrum is what they call as the emerging AGI. That's where today's leading models sit. So whether it is your GPT 5.1 or the Gemini 3, these systems are the emerging AGI. These systems show early signs of generalization, and they are already strong on specific narrow tasks. The next rung up is competent systems that can match an average human across a wide range of tasks. So it's like one machine that can do better in all the tasks than an average human in a particular task. And above that is expert systems that rival the very best humans in most fields. Then is virtuoso, going beyond the best consistently across domains. And finally, there is superhuman, where systems can do things we simply can't. That includes autonomous science, new theories, etc. So we are at the first level, or the emerging AI, the AGI. My bad. So now if we quickly look into Anthropic. So Anthropic, unlike OpenAI's focus on economic productivity, they focus on what is called as powerful AI, and they look into safety, and they from a security and safety angle, what they generally look. So operationally, they define AGI as a system that's smarter than a Nobel laureate across domains and capable of acting coherently over long time spans, which includes days or even weeks. But when it comes to validation, Anthropic takes a governance first approach. So they only do it based on responsible scaling and constitutional AI, which we will have a brief look in the next slide. So they take it from the lens of risk and safety. At the early stage, you have systems that look like general reasoning agents, which can multitask, set goals, act with some autonomy. Then comes AGI proper. And beyond that, the real concern is the inflection point, when systems become dangerous through manipulation or evasion, and when they become transformative with large-scale economic or political impact. So Anthropic tracks 3 big signals for this: whether the systems can sustain goals over time, whether they can act autonomously with expertise, and whether they take on the character of agents that may or may not be controlled. Let's go to the next slide, where we will look into Jan LeCun's view of intelligence. By the way, Jan LeCun is the recipient of third Turing Award recipient for AI or deep learning. So they are known as the godfathers of deep learning, including Jan LeCun, Joshua Bengio, and Hinder. So LeCun calls, he basically talks of what he calls as advanced machine intelligence, or AMI, which is the closest to AGI in general terms. So this view challenges the idea that scaling language models alone is not a path to the intelligence. Instead, he wants to look at it from a modular self-supervised system, which are grounded in real-world interaction. So operationally, AMI combines multiple capabilities, which includes perception, memory, world modeling, planning, and action leading to objective. And it relies on internal models to pursue goals and make decisions. So let's go to the next slide. So to make this concrete, LeCun outlines a functional loop for intelligence. He proposes a modular architecture with components of perception, world models, planning, reasoning, and action, all working toward a configurable goals of objective-driven AI architecture. They learn through self-supervised representation learning and predictive world model objectives. So let's go to the next slide. In the interest of time, I will skip this, but it is highly recommended that do have a look at Jan LeCun's one of the talks. He consistently been using the similar set of deck with minor changes here and there for few years. So please do have a look at one of his recent talks. This slide was lifted from his, that's the slide, the previous slide that you were seeing was lifted from one of his talks. So I will encourage you to have a look at it. I will skip this in the interest of time and go to era of experience. So this is a fundamental view put forward by Richard Sutton. So instead of learning from pre-collected data sets like text scrapped from web, agents now generate their own training data through interaction. This is the fundamental shift that Sutton proposes in this era of experience. So it includes perception, action, feedback, temporal memory. And in this setup, intelligence is shaped through experience based on the data these systems acquire from their environments. So let's go to the next slide. The shift is defined by four key properties. These include streams of experience. Agents operate over long horizons, not one-shot tasks. Grounded interactions, environment-based rewards, and planning through simulation, which is basically the experience-grounded planning. So LLMs face diminishing returns from human data alone. As we exhaust high-quality examples, bigger gains demand experiential learning, and that is the fundamental argument that Sutton puts forward. Let's go to, and why does this matter? Let's go to the previous slide. So because at scale, human data is finite, and systems that learn through own experience can scale adaptively. This is already evident in systems like AlphaProof, robotic stacks, and even model-based planning agents. So the point is not to discard language models, but to recognize where they plateau and where experiential learning offers a path forward. So let's go to the next slide. So the framework for this era of experience or experiential learning is put forward by Oak. Again, Sutton puts forward it as Oak architecture, which is options and knowledge. So agents should learn their own options, meaning temporal abstractions, and their own knowledge involving predictive models, feature abstractions directly from experience. The architecture keeps inductive bias deliberately minimal. Here, Sutton being famous for the reinforcement learning. So reinforcement learning forms the substrate here, temporal abstraction and continual update. So the strength of this approach is that it shows how predictive knowledge can emerge bottom up without hand-engineered priors. So even today in our systems, we have some form of prior which are hand-engineered, at least at the learning phase or the design phase. So what Sutton proposes is to rely as minimally as possible on those priors. So let's go to the next slide. So if we take a step back and look at the larger arguments that typically certain camp provides, is that it is always to design general algorithms. The idea is to build learners that can discover features and rules for themselves. Human design features are brittle, learned ones scale. Second is to exploit compute. So here a fundamental assumption here is that compute is massive, or the assumption is that compute is infinite, which need not be a practical assumption, but it still nevertheless is a valuable assumption to rethink about a framework. And third is to shape objectives and not content. So focus on rewards, benchmarks, and setups rather than trying to hardwire in specific knowledge. And finally, favor universality. So domain agnostic architectures may feel slower in the short term, but keep scaling. Domain hacks give you a quick win, but universals are what carry you forward. Let's go to the next slide. So now here are some gaps that we observe in the the argument that OC puts forward. So first, knowledge gaps. By defining knowledge narrowly as predictive models, the approach ignores tacit social and cultural forms that humans depend on. Second is the alignment gap. Relying on scalar rewards and outcome-only alignment risks reward misspecification, where the system hits the metric but fails on process quality and richer human values. And third, ethical and contextual gaps. The concern is opacity, a lack of embedded fairness and norms, and fragility when behavior shifts across contexts. So critics argue that certain camp outcome-driven view of knowledge and alignment is brittle. They suggest richer models instead, which integrate tacit and social dimensions, shaping rewards through human feedback and trajectory quality. So now let's go to the next slide. So to drive home the point of what is the problem with this predictive models and their scalar rewards, is that let's look at hyperlocal delivery, the Zeptos and the Zomatos and the Swiggies, right? So the hyperlocal delivery, if you think of it like an ox-style reward optimization, then naive reward signal would be that deliver items within 10 minutes. So what happens? Delivery agents rush. So if you are ordering eggs, then eggs arrive cracked, food arrives stale. Systems optimize for speed but ignore quality and experience. This is exactly reward misspecification. The defined outcome is met, but the true outcome customers' values is not. So what all should be the reward accounting for? Should it be just deliver in 10 minutes? Or should it be deliver fresh egg in 10 minutes? Or is it like deliver unbroken fresh eggs in 10 minutes? And now what happens if there is curd also along with to be delivered with eggs? And if it keeps on increasing, where do we stop with our reward specification? So this is one fundamental issue that scalar models typically ignore. So knowledge, or more broadly thought, isn't flat. This is often not discussed well. So knowledge or thought, it comes in layers. Some kind of knowledge are abstract and foundational, while others are operational and embedded in practice. So to capture this, I use a 6-layer scaffold that moves from the most abstract to most concrete. At the top is philosophy, the worldview or ontology an agent holds. It is largely tacit, often shaped through lived experience or socialization, and it determines how the environment is interpreted before any action is taken. Then comes principles, where rules or values distill from experience. These are general commitments, heuristics, or alignment guides that emerge over time. Next are frameworks, which are structured models that organize thought. Frameworks provide reusable blueprints for reasoning, giving agents a way to structure unfamiliar domains. Beneath that are processes, the actual reasoning and planning routines. These are stepwise methods that operationalize frameworks and can be applied across tasks. Then comes practices, which are context-sensitive skills and strategies built and refined through repetition. And finally, at the base, we have tools, the concrete instruments, modules, or affordances that instantiate the rest. This include memory system, policies, or interfaces. So this scaffold from philosophy down to tools show how thought becomes operational. And this is where my 6-layer taxonomy comes in. It provides a structured way to specify what kind of knowledge should be learned at runtime, designed by humans, or explicitly encoded into an agent. So let's go back to the hyperlocal delivery example. The 10-minute promise that results in broken or stale eggs. How does my 6-layer taxonomy help us think about this problem differently? At the top, the philosophy layer, the worldview guiding the system. Here, it's not just about speed, it's that commerce is about building long-term relationships, not chasing short-term metrics. Then comes the principles, where a guiding rule is appearing, which is that customer trust requires reliable quality, not just speed. That's the lens through which performance should not be judged. Next is the framework layer, where how success is measured. Instead of a singular scalar like 10-minute delivery, the framework involves KPIs that balance speed, quality, and customer satisfaction. Below that are the processes. These are the logistics, workflows, dispatch rules, and quality control checks that make the framework real in day-to-day operation. Then comes the practice, the skills and habits of the people involved, delivery agents handling the eggs carefully, communicating delays honestly, and all those. And finally, at the base, we have tools that includes better routing apps, safer bikes, better packaging technologies, etc. So instead of saying deliver in 10 minutes, this layered view makes clear what kind of knowledge and design need to be in place from philosophy down to tools to deliver not just speed, but real customer value. And what I'm speaking has a grounding on some of the foundational theories in knowledge management, which we will see in the next slide, the Secchi model. So the shift we are seeing with the era of experience is a meaningful one. Rather than depending solely on static human annotated data set, it focuses on learning through direct interaction. So this is a practical response to a real bottleneck. We are running out of new high quality corporate. But the limitation is not about quantity, it's also about the kind. If you look at it, a great deal of human knowledge never makes it into training data, not because it doesn't exist, but because it is tacit. It's the kind of knowledge that lives in routine, that is shaped by lived experiences, which rarely gets written down. This includes how a nurse manages a patient's anxiety, or how a skilled negotiator reads the room and shifts tone. So a well-known story from the field of knowledge management captures this gap. When Panasonic set out to build a bread maker in the 1990s, they struggled to create breads that cooked uniformly. They even tried doing an X-ray of these breads. Finally, their breakthrough came from sending their lead engineer to apprentice under a master baker. So by observing how the baker stretched the dough, they were able to encode the intuition into the machine. So that process, turning lived experience into actionable design, led to what would become one of Japan's best-selling home appliances. This process was later formalized as the Secchi model. I would say it is further generalized. It's not just one process. So it is a framework that explains how knowledge cycles between tacit and explicit forms through socialization, externalization, combination, and internalization. And while the original Secchi model is intended for human to human or a human with a society interaction, but now as AI systems begin to learn from their own experience, we still haven't fully tapped into human experience. And not the kind that shows up in books, but the kind that's embodied, hard-won, and distributed across practice. So we should start from this premise where we ask, what if we could scaffold human reflection in a way that surfaces this tacit knowledge? So by creating agents that help bring out the wisdom into the world. The Secchi model gives us a lens for this and helps bridge the promise of experiential AI with the richness of human learning. So let's go to the next slide where we try to summarize or rewind what were the different perspectives that we have looked into. So first, we have the hype and the question surrounding AGI. The public tends to leap to the idea of sentience when discussing AGI. However, it's not a simple on-off switch scenario. The core story is really about understanding the definitions, timelines, and architectures involved. This is where the real nuance lies. Next, we ask, what is AGI and who gets to define it? There are competing visions from major players like OpenAI, DeepMind, Anthropic, and from LinkedIn. They all have unique perspectives. It's crucial to view AGI as a staircase with gradual steps rather than a binary light switch. Organizations like Anthropic and DeepMind suggest phased thresholds that illustrate this gradual development. Now, moving on to timelines and tensions, predictions for AGI's arrival vary widely, from brink of realization to several decades away. We are already seeing proto-AGI elements in current tools, which adds layers to ongoing debates about risks and scaling of these technologies. Finally, we explored the architectures of real intelligence. Lequin's model proposes a sequence, perception, world model, planning, and action. This approach emphasizes grounded autonomous learning, moving beyond mere token prediction. It suggests a future where systems learn in a more human-like manner through experience and adaptation. So together, these elements paint a complex picture of AGI's potential path forward. Let's keep these ideas in mind as we continue exploring how experience will play a pivotal role in the next stages of AGI development. Now let's go to the next slide. So let's look into the era of experience and how it reshapes our understanding of intelligence. Here, we move beyond static human datasets, venturing into agent-generated data through action. This shift emphasizes the importance of learning from mistakes, embracing embodiment, and leveraging feedback loops. It's about transforming raw experience into actionable insight. We also looked at how the Secchi model integrates with this transformation. Secchi describes the journey of tacit human knowledge becoming explicit and usable. And the 6-layer scaffold reflects this journey, providing a clear hierarchy from philosophy down to tools, bridging abstraction to action. It also gives us a way to decide what kinds of knowledge should be encoded at design time, learned at runtime, or discovered through experience. Together, Secchi and the taxonomy show how experience matures into structured intelligence. And as we move towards the final reflection, remember, signs of true AGI will include grounded planning, continual memory, and real-world agents. Simply scaling data or models won't suffice. What truly matters is the depth of experience and structure it brings. AGI will require layered growth, reflection, planning, practice, and action. Ultimately, if AGI emerges, it won't be from just amassing data, but from cultivating deeper, richer experiences. And yeah, so that's more or less what I wanted to cover. I will be happy to take a question or two if we have time.
Amarth, what's your take on AGI? Whether it's achievable in near future?
So I would personally be, my personal opinion here would be with the likes of Jan LeQuinn. That is like, we need to fundamentally redesign. We need to go back to, again, the drawing board to figure out how to really achieve AGI, where the assumption of AGI is like a malleable intelligence or a human-like intelligence. A human-like intelligence means that a human can learn something very quickly, something in a very short span of time with limited training as compared to a machine. So that is something that I personally believe is the way it looks like. But I think some of the most prominent people sit in this 5 to 20 year timeline. So those include Jeffrey Hinton and Dennis Hazzabis and others. So they think that in 5 to 20 years, this breakthrough is possible. Yeah, so that's where it currently is. So I am probably split between this fundamental reinvention and maybe that is possible in 5 to 20 years, given the individual components are there. But one thing that is certain is that whatever we have built so far, it is not going to be it is always going to be built on top of it. I don't think reinventing the wheel is required. And that's why the Stanford Human AI Center had confidently called whatever we have built in the recent times as foundational models, because whatever we are going to build, it is going to be on top of it, because the gains are clear, but it is not quite there to achieve something that is AGI. Are there any other questions? So I'll just add one more point, that there was a recent podcast from Ilya Sutsvika where he actually says that 2020 to 25 was the years of scaling, and now we have to go to drawing board, or we have to go back to research to figure out the next trend year. And it matters a lot because he was one of the biggest proponents of scaling. So when he comes back and when he tones down, it actually makes a lot of impact. So probably, yes, it's quite true that we are hitting the ceiling with what scaling can do. Or I would say scaling alone can do.
Participants, if you have any more questions, you can ask. Looks like there are no more questions.
Sure. So thanks a lot for the opportunity. It was quite fun, and it was quite great to present my views here. Thanks.
Thank you, Amar.